I did a bit of digging on why we're not getting the same quartile answer as we got when we did it by hand. And the short answer is that Excel does not calculate quartiles correctly. Well, it does them more as a percentile averaging based process. And actually, there's a few different types of quartile functions in Excel. But I'm just going to go ahead and say don't use these because they will not come out correctly to how we have defined them in our textbook. So anyways, there are other calculators you can find online if you really would like to check yourself, or if you are not getting the right answer, but don't use that that I used in the last video. Another thing that we can check is the standard deviation, and let's also look into box plots as well. So standard deviation is actually quite easy to do, but I did want to warn you that there are different types, there are different, I'll just say STD is a common marking for standard deviation, and maybe I'll do standard STDev because STD sounds like something else that I won't mention, but yeah. So how to do standard deviation in Excel is if you start off with STDEV, notice that that would give us our standard deviation function. There's a few different ones, and what I wanted to sort of point you at is what is the correct one that I want to use. So STDEV.P stands for the population standard deviation. You only want to use this, and this is a very slightly different formula. This is going back to the n versus n minus 1 thing I was talking about in our standard deviation lecture video. But basically, only if you know the entire population would you want to use the standard deviation.p function, but standard deviation.s stands for the sample standard deviation, which in these data sets, we're assuming that we're finding out some of the data, but not necessarily every single data point that makes sense. And that's kind of the reason why you want to use that. But basically, standard deviation.s, this will be the same formula that we have in our book here for 1 divided by n minus 1, the square root of the variance using n minus 1 degrees of freedom. And in the same sort of way, when you're using the standard deviation, you want to make sure you just select all your data. I believe that's all you need, and it will calculate the standard deviation for our... And I momentarily confused myself because the standard deviation I was getting was not the same as our example, but then I realized that we found the standard deviation for Amanda's 7 test scores, or quiz scores rather, and not this. But if you want to know, well, what was the standard deviation of the ages of our students, the standard deviation came out to 5.7 for the ages. And again, that's a measure of the variability of our data. And the closer it is to 0, meaning less. And since we had a few students, well, mainly Gladys, who was much older, it made the standard deviation quite a bit further away from 0. Now let's go ahead and do it for Amanda's quiz score. And we could check things such as the mean, median, and standard deviation in the same way. Let's go ahead and do that. So mean is equal average. And her 7 test scores are in the next tab. 87, that's what we got before. Perfect. The median, her median test score was 91. Oh yeah, that one was just is an odd number, so that one was really easy. Now the standard deviation, we got 15.64, and then when using standard deviation, make sure you use .s for data samples, and it's looking like we're going to come up with 15.64, and that is exactly what we got when we did it by hand. So that's a good quick check to make sure that we got that correct. Okay, let's go back to, let's do a quick box plot, and then we'll go ahead and wrap up this segment on Excel. So let's go back to the example where we made box plots for our age and GPA. Let's just go ahead and check our box plot for GPA and see how that works. And basically, in the same way that we made a histogram or a pie chart, notice that the box and whisker plot, that's just another way, and same thing as a box plot basically, which describes the data using the quartile range. So let's go ahead and look at the GPA. Excel will always do vertical box plots. So we can go ahead and try it out, see what we get. And like before, we can always mess around with our data. Notice that the y-axis here is quite a bit different from the y-axis that we created for our box plot, and it makes it look a little bit different. But just like we did in the other video about graphing and histograms, you can always edit the axes and customize them to whatever you want. So if you right-click that and go to Format Axis, we can actually make it look exactly like ours by making it start at 2, making that the minimum value of our box plot. And we can kind of just check to see how our box plot came out. Minimum was 2.2, maximum was 3.9, and then we had our median right at 3.55. Our third quartile was 3.8, and our first quartile was 2.5. And again, it looks a little bit different, and as we found out in recently, the way that Excel does the first and third quartiles is a little wonky, so take it with a grain of salt. And this is just a word of warning for all computers and calculators, and something that we'll experience as a frustration in this course sometimes is I'm getting different answers than this other resource. And the question can sometimes be, well, do I trust this resource? Usually we trust Excel, but sometimes things are programmed differently or strangely, and it's just something to be aware of. It exists. I would always trust the math by hand if it's done properly over things done by a computer. While we often we've grown up in a society where we really trust the answers that we get from calculators and such. It's really more important to understand the concepts and these things by definition over that of a computer. Anyways, that wraps up this little mini series on Excel. I'll continue to get more into Excel from time to time as the semester progresses. See you in class soon.